Good evening to panel, Dr. Noor Ashikin and Dr. Norida. My name is Madhivanan Sukumaran and my metric number is CN200084. My supervisor for PSM1 is Associate Professor T.S. Dr. Norani Binti Marsi. My title is Study on the Banana Peel Musa Paradisiaca as Biodegradable Plastic Thin Film on Plastic Car Seat Cover. Introduction will consist of 4 subchapters. We will one by one with explanation. Introduction. Banana peel waste are produced 3.5 million tons annually by food business worldwide. Banana peel contain 40% of the starch in green. Plant peel is converted to sugar during ripening, and compared to plantain peel, banana peel has less starch, approximately 15%. Banana byproducts are good sources for raw materials for industry recycling agriculture waste, which mostly used in food packaging industry. Background research. So the thin plastic filler is a protective layer in car seat cover to prevent damage and increase durability. The thin plastic film degrading process is very long to biodegrade, almost 100 years. There are two types of plastic thin film, which is petroleum based and natural source plastic thin film. Banana peel as wet cellular fiber, which good in alternative source and superior environment performance. Use of biodegradable material help to environment by biodegradation and lowering carbon dioxide. Polymer matrix based composite are effective methods and as alternative polymer which have thermoplastic matrix with other fillers such as PVC and PLA. Glycoside starch is a TPA, a thermoplastic starch made of starch and cellular fiber used to reinforce starch base to improve mechanical quality composite which can be biodegradability. Problem statement. Thin plastic film made of petroleum is difficult to degrade which cause environmental effect, but natural based film is more environmental and biodegradable than petroleum, but is more expensive. Food waste is a global issue from agriculture activities, including banana around 25 to 40%. Rising garbage causes high disposal cost and affect the environmental like methane and carbon dioxide gas. Banana peel 40% wastage from agriculture. The thermoplastic starch thin film will make plasticizing effect, improve tensile strength, water resistance and biodegradability. So objective of this title is to formulate biodegradable plastic thin film under different concentration of banana peel and to evaluate the physical and mechanical properties of the biodegradable plastic thin film. So scope. The first one is the formation of the thermoplastic starch under the concentration of the banana peel as a filler. In the table we can see there will be 5 samples A, B, C, D and E. Banana peel as a filler, wheat starch, glycerol and distilled water as a matrix of thermoplastic starch. The second one, to evaluate physical and mechanical properties of the biodegradable plastic thin film. In physical test, there will be scanning electron microscope SEM test, energy disappear X-ray EDX test, density and porosity test, biodegradability, thickness and mass determination test. For the mechanical test, there will be two, which is tensile and tear test. Literature review. So review all the relevant information related to this project from related article, journal and more. The information gained from the previous research study will help in problem solving and improve system configuration during the fabrication process. previous research. First one, abundance and distribution of macro and mesoplastic debris on selected beach in northern state of Malacca. In this article, the packaging in food industry has highly grown, which increase in plastic waste imports. This conclude increasing in plastic waste, government take action to reduce the plastic pollution has been stated. A review of future household waste management for sustainable environment in Malaysian cities. In Malaysia, packaging make up 48% of plastics in market, especially in plastic thin film by factor of convenience, cost effectiveness and product protection. Continue. Biodegradable plastic applications towards sustainability, a recent innovation in the green product. In this article, the use of biodegradable polymers in agriculture, particularly in mulching application, has various environmental benefits. Comparable to plastic film, biodegradable film can increase soil temperature and preserve oil. Tapioca starch film reinforced with microcrystalline cellulose for potential food packaging applications. The development of tapioca starch film reinforced with microcrystalline cellulose for potential food packaging application has been stated. Development of bioplastic from banana peel has stated that the starch must be granularized to produce a solution which is then diluted with butter for a period of time. The swelling effect of butter fuels the generalization process which breaks apart the amylase and amylopectin chain, rendering them wholly soluble. In this article, they stated they're using opal molding process, which is solution casting. The last part of literature review, preparation and characterization of biodegradable cassava starch thin film for potential food packaging application. The author used SCM analysis to examine the shape of native cassava starch to determine the microstructure of the thin films. The characteristics of demolarized dentin material sponge as guided bone degeneration based on the FTIR and SEM EDX test. The author used SEM and EDX analysis to examination to elemental composition of the thin film to identify the microstructure and nanostructure of the sample. Last one, improving the tensile and tear properties of thermoplastic starch or dolomite biocomposite film through sonication process. The author also determined the mechanical properties of the film. The test has been done is tensile strength, elongation at break, Young modulus tests on Instron machine. Methodology. In the methodology, we will see progress flow chart, sample preparation, and physical and mechanical testing. So, this is the progress flow chart of biodegradable plastic thin film. Material and composition ratio. There will be glycerol, wheat starch, and banana peel. So there will be 5 samples A, B, C, D, and E. Banana peel as a filler. Wheat starch, glycerol, and distilled water as a matrix of thermoplastic starch. Process of manufacturing biodegradable plastic thin film. Firstly, we can see banana peel. So preparation of the banana peel. Cut the banana peel into 2 times 2 cm. Then The drying process of the banana peel will be conducted. After that, grinding the dried banana peel. banana peel. After that, extraction process of banana peel using maceration extraction method. Then preparation of thermoplastic starch as matrix will be done. Finally, the mixture will pour into a open molding. The mixture will aggregate slowly with a sepulchre to ensure that both solutions were truly combined until were no visible meshes or bubbles. So, for physical tests, there will be scanning electron microscope SEM, energy dissipation X-ray EDX, thickness, density and porosity, biodegradability, and the mass. For the SEM, the ASTM E150812A will be used to determine the microstructure of the sample, and EDX analyze testing will be conducted at the same times when we conducting the SEM test because using the same machine. The thickness of the sample will be measured by using vernier caliper. The biodegradability test will be conducted by solubility according to ASTM D598818. The mass will be calculated before and after of the biodegradation process of the thin film. As said earlier, for mechanical tests there will be two tests, which is tensile strength test and tear resistance test. The tensile strength test will be done according to ASTM D638 is to determine the maximum load, breaking force and elongation at break. We'll clamp the sample at clamping unit at UTM machine 20" per minute and load the force maximum 10 Newton force will be delivered to the sample until the specimen break into two parts. The data will be recorded in the digital form such as Excel. So for the tear resistance test will be done according to ASTM D1938 is to determine the flexible by the tear resistance. The Thousand shape rib test which the sample will divided into two legs to clamp at the clamping unit at universal testing machine. This test also will conduct until the sample break into two parts. So, in this process, the result we expected is 10% of the banana peel is best to produce biodegradable thin film because the result will be less weight, more flexible and good in mechanical properties such as great tensile strength and tear to the resistance. The biodegradable plastic thin film which will have a shorter time to biodegrade. The SEM and the EDX analysis will show the microstructure and the nanoparticle of the sample for A to E. The sample B may have the physical and mechanical properties that must have in the biodegradable plastic thin film. So the conclusion. This study will explain about the physical and mechanical characteristics of the biodegradable plastic thin film made from banana peel Musa Paradisiaca for plastic car seat cover. Plasticizing with starch with glycerol and distilled water. The matrix of composite involved in preparation of thermoplastic starch process. The filler material for preparation of banana peel as three stage. Preparation of three stage which is drying, grinding, extraction. Then will be molded. The 8 sample will be prepared for each concentration of banana peel for testing a variety of testing to determine the physical and mechanical properties and qualities. The outcome. and discussion will be clarify the mechanical property of biodegradable plastic thin film and will examine the density of the sample and how resistant is to the external pressure and impacts. So this is the Gantt chart for PSM1 from find the title and scope objective problem statement for the title until we do the full thesis report for the PSM1 and the presentation. That's all from me. Thank you for listening my presentation.